Okay, so good evening, guys. Good evening, everyone. So I think till last session, I talked about pandas. So I think in last two session, we talked about. Okay, let me first share my screen. Okay, so I think in last two session we talk about a NumPy, then we talk about pandas. Okay, so today I am going to talk about like some visualization libraries. So as I told you that like NumPy is for a NumPy stands for a numerical Python. It is for a scientific computation. Okay, so scientific computation means any kind of a mathematical calculation, any kind of any kind of calculation based on a matrix, based on what we can call it as maybe a two-dimensional, three-dimensional matrix. Because whenever we have a data, so I think in last session when I talked about a panda, so you see that I have some kind of a data along with me in the form of a data frame, in form of a series. And pandas is used for a manipulation. Okay, so we are trying to arrange the data in a proper format, and then we are trying to analyze it also. Okay, so analyze it, how I'm trying to analyze it. So I'm trying to analyze it, and even I'm trying to clean my data set, because my data set is like a little bit like noisy, because I have some null values, I have some irrelevant values, I can say. Whenever I have, or whenever we have this kind of information in our data set, we need to perform this kind, we need to analyze it, we need to manipulate it, we need to remove those particular noise. Okay, and I think that yesterday also I talked about that PGP session. And maybe whenever, if you meet me in that particular 5 or 6 months program, so definitely we are going to discuss all these things in a very detail, in a depth. Okay, so in a depth means, yeah, we are going to discuss all these topics, all these things. Okay, so these are the things which we need to generalize, we need to analyze, we need to remove the outliers, we need to remove the noise, we need to handle the null values, we need to remove the irrelevant features. Okay, we need to maybe rename some feature, like yesterday we did this kind of a task yesterday. Okay, now even to now there is another concept, there is another like a functionality, or there is another feature which Python provides you in form of a visualization, in form of a graphs. Like, you can analyze your data. Okay, so definitely with the help of pandas also it is possible, but you can try to show the graph. Okay, so you can try to analyze your data, and you can try to explore your data. You can perform the statistical analysis. So as I think every time whenever I perform this kind of a task, so every time I will definitely going to tell you that we need to we need to perform a statistical analysis, because statistics, and that is why statistics and probability is considered to be a backbone of machine learning, like any kind of a machine learning program. Because that is a kind of a requirement. Okay, so whenever we need to perform this kind of analysis, maybe a statistical analysis, maybe a normal analysis, maybe like exploring the data, so we need to use some graph to analyze our thing, even to show that, yeah, this is the kind of a thing which is going on inside my data set. Okay, so fine, guys. Let's start with this visualization libraries. So there are two popular libraries which is available inside of Python. One is Matplotlib, another one is Seaborn. So I'm going to take both simultaneously in the same session, and and definitely I'm going to take one data set also to explain some of the functionality of this visualization libraries. Okay, so let me import it first. Okay, so first we need to import this particular libraries. Okay, so before importing that, we need to import our previous libraries, because definitely we are going to use it somewhere. So we need to import a numpy. Then we need to import a pandas. Then we need to import a matplotlib. So matplotlib is for visualization. And then I need to import a seaborn. Okay, so these are the like four libraries which I have imported to continue my task for today. Okay, I just start with a very basic, like a very like common graph. Okay, so suppose I have two axes. On the x-axis, maybe I want to have maybe something, and on y-axis I want to have something. Okay, so maybe I can create this kind of a thought: yield mangoes, and then I can. Okay, so I can try to write the yield in terms of per hectare. Okay, so maybe it may be 0.80, it may be 0.83, it may be 0.79, it may be 0.84, it may be 0.87, it may be 0.82. Okay, and it's fine. Then I can try to write years on maybe one axis. So I can start with a 2014, then a 2015, then a 2016, then a 2017, then 2018, and then 2019. Okay, so 1, 2, 3, 4, 5, and 6. So 6 years are there. So I think this is the yield per hectare, and then according to the years. So I want to plot it. Okay, so if I want to plot it, so how I can plot it? I can by using a plt dot plot. So this is going to give you the line plot. Okay, so by default, when so there are different kinds of plotting available inside a matplotlib, inside a matplotlib also, and even inside a seaborn. Okay, so both the libraries is like provide you. Like kind of a functionality, a different kind of a graphs. Okay, so a lot of different varieties of a graph. Okay, but by default it is always going to be a line chart or line plot. Okay, and inside a line plot you need to give some continuous variable on the y-axis, or maybe like a numerical variable, you can say, on the x-axis, and even a numerical variable on the y-axis. Okay, so this is a kind of a graph I am getting over here. Okay, maybe I can add one more here to so that it will be look more fantastic. Okay, so up down kind of a graph, because maybe in 2014 I am having a 0.80, then 0.83, then 0.79, then 0.84, then 0.87, and then 0.82, then 0.88. Okay, so this is a kind of a graph I am getting for mangoes. Okay, so yeah, I am able to plot it. It's simple, easy to plot, like a library, easy to plot a graph. And now suppose if you have this kind of graph with you. Okay, definitely this is a kind of a dummy data set which I am creating. Okay, so I have created just a list. Okay, definitely you saw in the last session itself that I may have I may have like a bunch of data set. May have a bunch of information, a bunch of examples. Okay, so but I have created a dummy data set over here with just 7 examples, so this is fine. But suppose if you have if you are having this graph only. Okay, so just hypothetically suppose that maybe for maybe even for a 30 information, or maybe for 30, 40, 50 examples, maybe you are having this kind of a graph only. Then also you can make some conclusion, you can make some decision, you can like make some hypothesis in your mind. Okay, so this is might be a scenario in future. Okay, or this is might be this is what I am able to this is kind of information I am able to get from this data set. Okay, this is the meaning of an EDA. Okay, so tomorrow I am going to explore this session. I am going to talk about in much detail about EDA, which stands for exploratory data analysis. So exploratory data analysis means the same. Okay, it means we are trying to explore the data and we are trying to analyze it. We are trying to get we are trying to extract as much information we can extract from my data set. Okay, so here I can make my conclusion. I can like make my I can say, okay, so I'm able to extract the information, and the information states that the yield of mangoes is is like up and down. Okay, so one year it goes up, then like alternative year it goes down, then again it goes up, then again it goes down. Okay, maybe for consecutive 2 years it goes up, then it goes down. Okay, so this is a kind of a scenario I am getting over here. This is kind of information I am getting with this graph. Okay, similarly you can try to plot maybe one more graph in a similar way. Maybe you can try to check the yield for the apple also, maybe oranges also, and then you can try to plot both the things. You can try to plot both like the scenario on the same chart. Okay, so here you have like you have just one graph right now. So in a same graph, in a same like a portion, you can try to plot both the chart together. Okay, so this is a kind of a benefit this, and even with the different colors. Okay, so if I can show you, suppose I can try to plot maybe the apples, for apples. Okay, so let take this example so that you are able to see also that what I'm trying to make you understand. So it may be a 0.78, it may be a 0.81, it may be 0.82, it may be a 0.80, it may be 0.84, then 85, and then maybe 83. And now I need to plot this. I want to plot the same thing. Here I'm having apples. Okay. Oh, yeah. Okay. So this is a kind of a graph I am getting for like apples. Okay. So for consecutive 2 3 years, I am my graph is increasing. Then I don't know that maybe some kind of some kind of a changes happen, or maybe any kind of maybe a maybe any kind of disaster may happen, and because of that at that in that particular year I have less yield. Then after again after that the graph is goes on increasing, and then the last year maybe because of the covid or something, the graph is again goes down a very little bit. Okay, so this kind of a decision I can make. I can write down this conclusion in a markdown. Okay, so here I can try to write like a markdown also. Okay, so whatever the things I'm going to write over here, this is a kind of a statement. Okay, this is not a code. Okay, so whenever you have some like conclusion or anything, so you can try to use a markdown, and inside that markdown you can try to write down the you can try to write down your conclusion, your analysis. You can talk about your analysis over here. Okay, fine. So these things are possible. Now let's try to plot the like both the graph. Try to plot both the graphs together. Okay, how I can plot both the graphs together? Okay, so let's take this like at least one. Okay, so let's take this for mango. So I want to plot a mangoes over here. Even I want to plot a apple, so I just need to change the apple. Now you can like make some changes so that it will be like everyone is able to understand. So maybe I can use like a kind of a property, a parameter which is available inside this matplotlib. So a marker. So a marker S for mangoes, then a marker maybe uh, O for means a dot for apple, and then I can like try to give the position also. Okay, so because if you are able to see, then we don't have anything on the x-axis because I didn't return anything. Okay, although it is understandable that on the x-axis I am having a year, on the y-axis I am having a like yield per hectare, but I didn't mention it. Okay, so yeah, you if you mention it, so it will be like a very good thing. So I can try to write x label over here. So I can label it in years, then a plt dot y label, and I can try to write down as yield per hectare, and then a plt dot legend, and here I can try to write down as like first is for mangoes, and then second is for apples. Now I can plot it. Okay. So yes, you can see that this is a like yield for apples and this is a like yield for mangoes. Now you can make a bivariate analysis. So bivariate analysis means whenever you try to take two variable together. Okay. So here I'm trying to take two variables, means two things together. I'm taking a graph of like mango and apple together, and that is why I'm able to plot it together. Okay, so I'm able like this is a graph for mangoes and this is a graph for apples, and now I can try to write down my decision. I can try to my whatever the like analysis I am having, so I can try to write down that information in by making a markdown. And here I can make a comparative analysis. Okay, that what kind of I can do the comparison that where the yield is high, okay, or maybe where the yield is low. So I can make that comparison between mangoes and apples. Okay, so fine. These things are possible. You can make this kind of like a conclusion, this kind of like a markdown, this kind of analysis you can make, and yeah, this yeah, you are having a graph which can better which can give you the better scenario, which can give you the like better understanding. Okay, so fine, guys. I think this is like a simple scenario I have created with this dummy data set. Now I'm going to take a actual data set. I'm going to take like a toy data set, a actual data set, which is definitely made for the beginners only. So I'm going to take that data set and then I'm going to plot like maybe the same thing and some more graphs to analyze like more information, to extract a more and more information. Okay, and to understand that what are the like functionality of all these different graphs. Okay, let me check if there is some query. Okay, fine. Okay, so let me introduce you the iris dataset. Okay, now iris is a dataset. Iris is a kind of a data set where you can say that this is a kind of a flower. Okay, so iris is a kind of a like a flower which is existing on this earth. Okay, so there are three kind of a flower. Okay, so there are three different kinds of a iris flower which is existing. So one is setosa, another one is versicolor, and the third one is virginica. Okay, so there are three kinds of a iris flower which is existing, which is existing on this earth: Setosa, versicolor, and virginica. Okay, now you know that there is like if you want to make some classification or like that okay, so this like maybe this flower is having this kind of a property, this flower is having that kind of a property, that flower is having that kind of a property. So every flower, each and every flower is having a different kind of a property, and that property may be based on their based on their petal length, petal width, sepal length, and sepal width. Okay, so I think we all learn this kind of a thing in our childhood, in our maybe class 9 or 10. okay, in our biology, that a flower having this kind of a feature, a petal length, petal width, sepal length, and sepal width. Okay, so now this data set is having this information. It is having a sepal length, a feature, sepal width feature, petal length feature, and petal width feature. Okay, so these four features are there. And then finally we have a label. Okay, so inside that label or inside that output column, we are having a setosa, we are having a versicolor, we are having a virginica. Okay, so these three classes we are having on the output. Okay, now as a machine learning engineer, okay, so definitely I'm not going to take that machine learning task into the account for today, but I'm just trying to give you the scenario. Okay, so this is a kind of a supervised learning task, because in case of a supervised learning task, you have a input data also and you have a output data also. Okay, so along with the input data, we have a output also, we have a label also. One second. Okay, so now, this is a kind of a supervised machine learning task. So, in case of a supervised machine learning task, what our objective is, we have a input data also, we have a output data also, and we need to find out maybe any new flower come into the existence or any new data comes into the existence. So, we need to classify that which category this new instance is going to belong. Okay, so maybe after here I'm having a 150 examples. Okay, so I'm having 150 examples, means a 150 rows I'm having. And now suppose at 151st position and any new flower come into the existence. Okay, so its sepal length, sepal width, petal length, and petal width are given, and my objective is to classify that whether this flower is belonging to a setosa, virginica, or versicolor. Okay, so this is a machine learning task which we are having. Now I today we don't need to focus on the machine learning task. Today our objective is we need to extract or we need to analyze as much information we can by making some like a graphs, by making some very beautiful graphs with the help of these two libraries, matplotlib and seaborn. Okay. Now, for that, we need to import the iris dataset first. We need to import the dataset first. Okay, so iris is my dataset, and to read this dataset, I think we know that pandas is having a kind of a function. Pandas is providing you the kind of a functionality to read this dataset. Pd.read CSV, and I need to give my name of my dataset. Okay, so it should be iris, and then I just dot it. Okay, so this is my data set. I'm having four features: sepal length, sepal width, petal length, and petal width. Along with this, I'm having a output also. Fine. Now I'm having iris. Maybe I can check like the shape of my data set, so that I'm able to see that how many number of rows and columns I'm having. So I'm having 150 rows and 5 columns. Now, fine. So I'm able to see all my columns in front of me, so I don't need to draw it. What I can do is I just trying to plot a line chart again. Okay, because I'm like maybe we are familiar with the line chart till now, so I can try to plot a line chart over here with this new data set. And now you have 150 information together. Okay, they're all we are having just maybe a 6 7 information, but here we are having a 150 information. Now let's try to take a look, try to plot this thing, and here trying to understand that what kind of a analysis we can make. Okay, so a plt dot plot, and because we are having a very we are having 150 information together, so I need to mention the figure size so that we can easily visualize the thing. So I can increase the figure size. So maybe I can take 11 comma 9. So on the so this is the width. Okay, so 11 is width, and this is the like length. Okay, so this is going to be a iris. Okay. Now I think every one of you is able to see this graph or this chart, that what is going on over here, and definitely it is going to be numerical data only. Okay, so if you are wondering that why we are not able to see the output, so output is a categorical column. Okay, here we are having a Setosa, Virginica, and versicolor. So categories are there, objects are there. These are not the numerical values. So in a line chart, we can only plot the numerical data, a numerical value. Okay, so a sepal width, petal length, when petal width are having a numerical values or numerical data, so that is why I am able to plot it. Okay, so I am having a numerical data. I am able to draw this, plot this numerical data over here. Okay, so now just try to analyze it. That what kind of information this particular chart or particular graph is going to give you. Okay, so if you try to visualize it, so I can see the variation. Okay, so I can see the variation in my data set or in my features. Okay, so I can try to analyze that which feature is more is having a more variance. Okay, variance means a fluctuation. Okay, so which of these features having a maximum fluctuation. Okay, now you can try to write down one note for you if you like want it, that if your data set, if your feature is having a more variance. Okay, so whenever the feature which is having a maximum fluctuation or which is having a maximum variance, it means that that particular feature is most important, is more important than the other. Okay, so whenever your like a feature or any particular column is having a more variance or maximum variance, it means that it conserve or it is having a maximum information in comparison to other feature or in comparison to other columns. Okay, so if you see if you try to see clearly, so this petal length is having a maximum fluctuation. Okay, so this petal length in comparison to any other feature, in comparison to any other feature, this particular petal length is having the maximum variation or maximum fluctuation. Okay, so it might possible the value start from maybe a 1. Okay, so the lowest value is 1, and the maximum value is maybe around a 6 point or maybe yeah, 6.8 something. Okay, and in comparison to this petal length, you are able to see a lesser fluctuation in any other feature. Okay, so even a petal width, even the petal width is not having this much of fluctuation. Sepal width is not having this much of fluctuation, and sepal length is also not having this much of fluctuation. Okay, so even you can try to make a comparison of like rest of the three, that so you can try to arrange them in ascending order, that this feature is most important than this, then this, then this. Okay, so based on their like fluctuation. Okay, so from here I can try to make a note, I can try to make my analysis, I can try to write down my markdown, that a petal length is maybe okay, although this is like just a graph which I am able to see, but then also based on this graph I can make my conclusion that petal length is maybe the most important feature in my data set. Okay, and even you can try to yeah, definitely we are going to see some more graphs, see some more plots which can make my hypothesis more valuable, which can provide it like more authenticity. But for now I can clearly say that yeah, this petal length is maybe the most important feature, or the more important feature in comparison to any other feature in my data set. Okay, now just try to take a glimpse of some other kind of a plotting also. Okay, let me take. Yesterday I faced the same problem. There is a problem in. Okay, fine. Let me check and I will. Uh, Fluctuations not clear. Fluctuation means variations. Okay, so variance. Okay, so there is in case of a statistics, there are some like descriptive and descriptive statistics like a mean, median, mode, and then standard deviation or the variance. Okay, so this is the meaning of fluctuation. So fluctuation means how much your value is deviated, how much you are deviated from the mean value. Okay, so mean means the average value. Okay, so it means that a fluctuation means how much you are deviated from the mean value, average value. Okay, that is what we call the fluctuation in a data set. Okay, now clear. Even you can take any example, any real life example. So you have some like destination to achieve, but you have some obstacles, and maybe you are finding some difficulty, so maybe you are deviated from your path, that you want to go somewhere, but you are deviated from your path because of some maybe because of some disturbance or anything. So you can try to check that how much I am deviated from my path. So that is what we call a fluctuation. Okay. Now, I can try to take some other plotting. So a scatter plot. Okay. Now, a scatter plot is also going to give me a very good insight, a very good observation. Okay. Let's try to take that a particular observation. So a PLT dot figure, and then I can try to give a fixed size over here. SNS dot scatter plot. And in case of a scatter plot also, you have something on the x-axis, and you need to put something on the y-axis. You can only take two variables. Okay, so on the x-axis I can try to put a petal length. Okay, because I'm pretty much sure from the line plot that petal length is maybe the most important feature. So even you can change it. I can try to understand you with the same different plot also, but for now I can try to take a petal length on the x-axis, and a petal width on the y-axis. Okay, now if you like able to analyze, or if you are able to see this scatter plot, so in so this data point, these points which you are able to see, which are are distinguished with the blue, red, and green color, blue, orange, and green color. So these are nothing but your data points. Okay, so you are having 150 data points or 150 examples in your data set. So these are nothing but this indicates your data points. And then on the x-axis you are having a petal length, and on the y-axis I am having a petal width. Okay, so now if I'm having a petal length on the x-axis and I'm having a petal width on the y-axis, and you can see that a setosa is represented by a blue color, versicolor is represented by a orange color, and virginica is represented by a green color. Now, taking this particular graph into a consideration, suppose if you take this graph into a consideration, so from here also you can make a one hypothetical decision. Okay, from here also you can make one hypothetical decision, means you can make one hypothetical machine learning model here itself. Okay, now how is it possible, how is that possible? So simple, it's like very simple to understand. If you try to draw a line over here. Okay, so in case of a machine learning model also, you are trying to plot a boundary. Okay, a boundary between two classes, or maybe boundary between three different classes. So the boundary is not possible over here, because if you try to make a boundary over here, so definitely there will be some noise. You may have some misclassification. but you can draw a very clear and very a wide boundary on this place, and this is possible. This is possible. Okay. And now if you are able to make this boundary, so you can say that the petal length if the petal length is lesser than 2 point maybe a 5 or maybe 2.3 or anything, whatever whatever you think that this value might be. Okay, so might be this value is 2.5. So I can clearly say that if the petal length is lesser than 2.5. Okay, now this is going to be a prediction. Okay, this is what we are trying to make with the machine learning model too. Okay, so this is a very clear prediction that if the petal length is lesser than 2.5. Okay, so suppose if you have if you get a new data set, or sorry, new flower. Okay, and if you just trying to check one information, that is a petal length. I'm not going to check another information, I'm just trying to check one information, that is petal length. And if my petal length is lesser than 2.5, so I can clearly state that this flower is definitely a setosa. Okay, I'm not able to make a distinguish. I'm not able to make a boundary for versicolor and a virginica, but I can make a very clear and very wide boundary for this. Okay, and I can clearly make this statement. Now even you can make this statement with respect to a petal width also, because maybe the boundary is not that much wide. Okay, but the boundary is possible. So even I can say if my petal width is lesser than maybe a zero point 0.8 or zero point 0.9, so that particular flower is definitely going to be a setosa. Okay, so at least for one class. Okay, so here we are having three class. At least for one class we can make this kind of a hypothesis, we can make this kind of a statement. Okay, and this is possible just because of this scatter plot. And now we can say that my petal length and petal width is maybe the most important feature, because I am able to make this classification model, this hypothetical classification model, with the help of this petal length and petal width. And now you are able to see that this kind of a thing is not possible with the sepal length and sepal width. Okay, so suppose if I try to take a sepal length and sepal width over here. Okay, so a sepal length and sepal width, just trying to take a look. Okay, so here I'm not able to make that boundary. Okay, although this is going to be maybe you are hypothetically you can say, okay, so I can try to make a boundary over here, but no, this is not possible. Even there is a kind of a mistake, there is a mistake. Okay, so with the sepal length and sepal width, I can't make this like a same kind of a boundary which I am able to make with the petal length and petal width. So I can clearly state that a petal length and petal width is much beautiful feature, is much maybe the important feature in comparison to a sepal length and sepal width. Okay, now you can ask me that how like suppose if I have some more feature, so I need to draw it again and again, so I need to like make this permutation combination again and again. No, you like you are not going to make this. You have one more kind of a plotting, that is called a pair plot. So you can make this pair. Okay, so a pair plot helps you to make all those combination which is possible. Okay, all those combination which is possible. So let me take like a query if there is any. Okay, no queries here. So fine, I can try to make a pair plot for you. So pair plot is nothing, it is going to give you the scatter plot of itself, but all the combinations. Okay, means a sepal length and sepal length and petal width. Okay, so all the combinations is you are able to see over here. So SNS dot pair plot, and then you need to pass a data over here. So data is nothing but a iris. Then you need to pass sorry color. So color I want to give on the outputs. Then I need to give the size, and it should be a plt dot show. Okay, so a pair plot will definitely take some time, because it is a you can say Okay, so pair plot, yeah, it will take some time because it try to like plot all the combinations. So with this much of information, we are having 16 combinations. Okay, so in total, we are having a 16 combinations. We are having a sepal length. You are able to see that sepal length and sepal width, then sepal length and petal width, petal length, sepal length, and petal width. Even you can see that wherever you have a petal length, you have some kind of a classification. You are able to make some kind of boundary. Okay, so sepal length and petal length, you can make this boundary, but not on corresponding with the sepal length. Here also you can make a boundary. With petal width also you can make a kind of a boundary. Okay, so wherever there is a like a petal length and petal width, wherever there is a petal length and petal width, at least you are able to make one boundary, maybe like a wide boundary, maybe a thin boundary, but yes, the boundary is possible. So that is why you can clearly state that petal length and petal width may be the most important feature or more important feature in comparison to a sepal length and sepal width. Although because we are not using any machine learning model till now, so although you can this can be a hypothetical statement, but yeah, this statement is possible because we are having at least some information, and at least this statement is completely possible. This statement may be completely true. The statement which you are making regarding the like a feature, okay, that sepal length, petal length and petal width is best. Okay, so yeah, this statement is definitely true. It's definitely a possible at all. Okay, now let's try to take a look of some more kind of a plot. Okay, so if I'm trying to plot a histogram and a distribution plot, okay, so let's take a look that what kind of analysis I can make with the help of a histogram and a distribution plot. Okay, and now this histogram and a distribution plot is totally it is going to give you a kind of a statistical analysis. Okay, but that statistical analysis is like maybe I think easy to understand. So I can plot it. So a plt dot hist, and then I need to pass. Now, in case of a histogram, it is going to give you the different kind of a graph. It is going to give you a different kind of information. So here you can pass like a single feature only. Okay, a single column only. Okay, so maybe I can take any column, maybe a petal length, maybe a sepal length, maybe a sepal width, or anything. So maybe I can try with the sepal length. And then there is one parameter which is called a bins. Okay, so I will tell you that what is this bins. Okay, now what kind of information this particular graph is giving you? Okay, so this graph is giving you the information that on the x-axis I'm having a sepal length. Okay, so on the x-axis I'm having a sepal length. Okay, so it starts from maybe a 4 and it goes till a 7.8. So I'm having a sepal length on the x-axis, and on the y-axis I'm having like a count. Okay, so this is nothing but a count that this much number of time I'm having 4.5, this much number of time I'm having a 7.5, this. So which so you can see that which number comes how many times, that which number come like maybe for the maximum number of time, which number comes maybe for the minimum number of time. Okay, so it actually shows you the frequency. Okay, a frequency that like frequency is what? Frequency is nothing but how much time this number is repeated. Okay, so you can see that the frequency of which number is high. Okay, so it started from maybe a 4, it goes till 7.8. So you can see that which which number is having a highest frequency. Okay, so you can see that a 5 is having like maybe the maximum frequency. Then a 5 point no, I think I don't think that 5, it is 4.9 or maybe a 4.8 which is having a maximum frequency. Then similarly a 5.6 or maybe 5.7 is having a maximum frequency. Okay, so this graph is able to tell you the frequency. Okay, so frequency of each data, frequency of each value in your data set. Okay, so frequency of each value in a column. So histogram is going to give you the frequency. Okay, and now this bean is nothing but this is the width of this like this graph. Okay, so suppose if I make this a 10, so it becomes a wider. Okay, so if I make it 20, so it becomes a thinner. Right? So this is a significance of a histogram. Fine. Similarly, we can see that what kind of a graph it is, like what kind of a distribution it is going to give you. Okay, so maybe sometimes you have a skewed data. Skewed data means most of the like a data may be on left side or maybe on the left right side, and you may have a very a proper normal data. Okay, so that is called a normal distribution. Okay, although these are the things which we need to learn, and which we learn in at a time of statistics class or maybe a probability class. But yeah, we always want our data to arrange in a proper normal distribution form. Okay, why? Because most of the distribution which is existing on this on this planet is like trying to follow a normal distribution curve. Okay, so normal distribution curve is nothing but a bell shaped curve. Okay, and why I want, and even we want to make any kind of a distribution to be a normal distribution. And why we want this? Because if your data follow a normal tendency means what? Suppose if I trying to take one survey. Okay, maybe on anything, maybe if I'm trying to take a survey of like maybe weights of a person. Okay, so in between the age of 25 to 35, I want to make a survey. And in the age group of 25 to 35, I'm just trying to take a weight of a person. So what do you think that in the age group of 25 to 35, what may be the possible weight of a person? Okay, so suppose if this question asked to you. Okay, so maybe you can give a range that that weight varies from 60 to 80. Okay, so if a person is 25, or maybe it's if his weight is in between 25 to 35, so definitely his weight is normally. Okay, so I'm talking about the normal person. Okay, I'm talking about the normal people. So most of the people is having a weight in between 60 to 80. Okay, so this is what my opinion, my personal opinion. Maybe your opinion may be a somewhat different. It may be a 5 kgs up or maybe 5 kgs down. That is completely possible. But general scenario, in a general scenario, if the person is in between 25 to 35, so definitely his weight should be maybe 60, in between 60 to 80. Okay, this is a normal tendency, this is a normal graph which we are supposed to make. But definitely there are some people, or maybe there are in maybe that particular distribution there are more people whose ease is lesser than 60 because of maybe some health issue or maybe something, or not maybe because they have improper diet. And it may also possible that in that particular distribution, that data which you have taken, it may possible that lot of the people is having a weight more than 80. Okay, because of like maybe they are overweight or something. Okay, so if we have this kind of a data where you don't have you have a more inappropriate value in comparison to a normal value, then you have a skewed graph. Okay, so it may skewed on the right hand side when you have a weight more than 80, and it may skew on the left hand side when you have a weight lesser than 60. Okay, but when you have a proper graph, suppose when you conduct a survey with a large population, with a large number of people, so definitely you get a graph where most of the people weight varies in between 60 to 80, and then you get a bell shaped curve, a normal distribution graph. Okay, so this is what we actually want every time in my data set. So suppose if you want to check that whether your data is normally distributed or not, so for that you can try to make a distribution plot. Okay, so I can try to make a distribution plot over here. Distribution plot. So I can try to write SNS dot dist plot. Then I'm having iris, sepal length, and now this is the kind of a graph I am getting. Okay, this is a graph I am getting. Okay, so this is a proper distribution plot. Okay, and now on the x-axis I'm having a values of the sepal length. Okay, and on the y-axis I'm having a probability. Okay, so on the y-axis I'm having a frequency, you can say a relative frequency. Okay, not a frequency, it's a relative frequency. Okay, now let's take another kind of a graph. So okay, not take another, not this, take this same distribution plot and try to analyze something. Okay, try to analyze trying to get some information from the data set itself. Okay, so let me take like a feature wise feature and then try to check. Okay, so let me what statement I make with a scatter plot. So with a scatter plot, I made a statement that petal length and petal width is the most important feature. So let me trying to preserve this statement. Let me trying to give more weightage to this statement by using this distribution plot. Okay, so I can try to write SNS dot a facet grade. Okay, so this grade is nothing but it is going to be a you are able to see a grid over here. Okay, then I can pass my data set iris. Then inside this I can give output. Then size may be a 5. Okay, and even guys, the like this is not a error. Okay, so always remember this is not a error. This is a kind of a warning which I am getting over here. Maybe because of the version or maybe something. So you can try to avoid this error. Okay, so always it is always up to you. You can try to avoid this error. So for this, what you need to do is you need to import a warnings, and then you need to run this command warnings uh, dot filter warnings, and then inside a bracket you can use ignore. So I think you have a warning over here also, so I hope that this time we didn't get any warning, and similarly we didn't get any warning over there. Yeah. Okay, so now I'm getting my plot without any warning. Now with this distribution plot, so I'm what I did is I tried to plot all the three varieties, all the three classes or categories of my data together, okay, with the petal length. And now you can see that here I can make a very a clear boundary over here, okay, with the petal length. And now you can try to analyze with all the four features. Okay, so just try to make it once. So in place of a petal length, I can make it a petal width. Then take a sepal length, and then take a sepal width. Okay. And now I think you guys are capable enough, even after seeing this, you guys are even capable enough by yourself that you can do like analysis by yourself also. Okay, so here that clear boundary is possible between Setosa, Versicolin, and Virginica. Even you can make a boundary in between Versicolin and Virginica with a very minimum error percentage. Okay, so suppose if I try to make it, so here, yeah, here the clear boundary is possible. Here the clear boundary is possible. I can clearly say that if my petal length is lesser than 2.5, so or maybe sorry 2.3, so that particular flower is going to be a setosa. This statement is completely possible with this graph. Now the second statement for a versicolor and virginica, so even here also we can make a plot because this overlapping is not very high. Okay, if you clearly see, the overlapping is not that much high. So even I can make a boundary over here and I can say that if my petal length is lesser than 4.8, okay, if my petal length is lesser than 4.8, or maybe I can say, I think it is like it is lesser than a 5.5. Okay, so if my petal length is lesser than 5.5 and greater than 2.3, because I need to take this also, so I can make this statement that if my petal length is lesser than 5.3 and greater than a 2.3, so that particular flower is versicolor with maybe with 95% confidence. I can see this statement, I can make this statement with 95% confidence because I it may have 5% of an error. Okay, because it is only making a 5 to 10% of an error, so I can even, okay, so maybe if I want to more if I want to if I want to be in more worst condition, then also I can say this statement with 90% of confidence. Okay, so 90% is very high value. Okay, so with 90% of confidence, even I can make a statement for virginica also that if my petal length is greater than 4 and lesser than 7.8, so it must be a virginica with 90% confidence. Okay, so in case of a petal length, if we consider just a petal length, we are not considering sepal length, sepal width, and petal width. If we are just considering a petal length, so with 100% possibility, with 100% confidence, I can classify one class, and with 90% confidence, I can classify two more class. Okay, so this is a kind of advantage we are having with this petal length. Now you can try to make a comparison with the petal width. So in a petal width, even the boundary is possible, but there is a slight overlapping, very slight. Okay, so I can make this statement with 99% confidence. There is 1% chance of an error, and then overlapping is high over here. Okay, so in comparison to this, the overlapping is definitely like probably little bit like higher in comparison to a petal length. And then if you come over here, if you come in the sepal length, so even you are not able to make a boundary for a setosa also. And if you come here, so here the condition is more worst. Okay, so you can clearly say that petal length is the most important. Then if you try to arrange in ascending order, so petal length, then petal width, then sepal length, and then sepal width. Okay, so these are the four features I can try to arrange all these features in accordance with their weightage. Okay, so whatever the exploration I make, whatever the graph I make, I can clearly say that petal length is the most important feature, in then petal width, then sepal length, and then sepal width. Okay, so this statement is completely possible with the graph which I make till now. Okay, so with the distribution plot, with the histogram, with you can say a scatter plot, with the line plot, all these four graphs indicates that petal length is the most important feature. Okay, so yeah guys, you we can make this kind of analysis, and this is this is the analysis which we want to make. This is the analysis which we want to make with any of my data set. This is the information which I want to extract. Okay, so here I am able to extract a very vital, a very important information, because like there is one concept, we use a different methodology to implement that concept, that is called a feature selection. But here, only with the help of some plots, I'm able to select my best feature. Okay, so this is a kind of a, if you are able to make this thing possible with a real world data set, so this is a kind of achievement, you can say about for you. Okay, so fine guys, tomorrow, I think this is it for today. Tomorrow I'm going to extend this topic a little bit with some more graphs, and with maybe a different data set. I'm trying to explore it, and then I'm trying to take maybe some theory on the, like maybe a kind of a regression and classification. And because before the practical I need just 5 or 10 minutes of theoretical concept also. So maybe tomorrow I am going to discuss this along with at regression and classification task, and then maybe on the final day I can wrap up the session by making some up prediction model, with by using all these concepts. Okay, so anyone having any query or anything you want to ask? And one more thing, guys. Now, as you are able to see that we are making this statistical analysis and all, and how much this statistical analysis is important. So, anyone, yeah, definitely, if you want to learn this thing in a detail, if you want to explore this thing, so you need to join our PGP session, PGP classes. So there we are definitely going to learn this thing in a depth. Okay, each and everything we are going to discuss in a depth, along with the and definitely we are having, at that time we are having a statistical knowledge also. Okay, so guys, anyone having any query or anything you want to ask? So yeah, you can ask. Otherwise, we can wrap up this session for today. Okay, and anyone from Let's Upgrade team, anyone here who can like tell me that, is there any query or we can wrap up the session? Okay, okay, guys. Okay, thank you so much. We'll meet tomorrow at the same time.